Okay, so this video is to finish up 8.1 notes. We're going to start with the summation notation. We have a new symbol. It is the Greek letter sigma. It's capital sigma. This is lowercase sigma that you use in statistics. Sigma in math means sum. So as you can see from the examples on this page, I give you a sigma and it's got some information at the bottom and at the top and out to the side. The bottom tells you where to start. It's called the index. It tells you where to start. The top tells you where to stop. And what's beside the sigma tells you what to do to it. And then the sigma part of it tells you to add as you go. So let's see what this looks like. So it's telling me to start with a 1. So I'm going to plug a 1 into this. So 3 times 1 is 3. And then I plus because of the sigma. And now I go to 2. So I'll plug a 2 into this and I get a 6. And then I add. And then I'm going to plug in a 3. And then I'm going to plug in a 4. And then I'm going to plug in a 5. And then you're going to add all these numbers together, and it's going to give you 45, which is your answer. Okay, so let's try 36. So 36 says I'm going to start with a 3. I'm going to go all the way to 6, and this is what I'm doing to those numbers. So let's start with a 3. So I'm going to plug a 3 in here. So that would be 1 plus 9. So that's a 10. Then the plus sign, again, because that's what the sigma means. So now I'm going to try 4. So plug 4 in, that'd be 1 plus 16. Then I'm going to plug a 5 in. And then I'm going to plug a 6 in. And then I'm going to add all those together and get 90. Okay, so 37. I want you to try it. I'm going to give you about a 30-second head start. Start with 1, go to 4. I got 44. And again, at any time during this video, you need to pause it so you can chew on something a little bit longer. Do so. This is so you can go at your own pace. Okay, 38. This is the sum from 1 to 4 of 7. Like, that's it, just 7. I have nothing to plug a 1, a 2, a 3, or a 4 into. So it's just a 7. So the sum from I don't care to wherever you want to go of a constant is just that constant. So if I did the sum from I equals 2 to 10,000 of 5, the answer is 5. Okay, so anytime there's a constant. Okay, so for number 39, I'm going to take a 2 and plug it in here, and I'm going to go all the way up to 5. So if I take a 2 and plug it in there, that'd be 2 cubed, which is 8, plus 2 is 10. Take a 3 and plug it in. That's going to be 27, plus 2 is 29. Take a 4 and plug it in. 4 cubed is 64, plus 2 is 66. And then 5 cubed is 125, plus 2 is 127. Add all that up, it's 232. Okay, so number 40 brings back our friend from the other day. This is in factorial. I'm going from 0 to 8, which is a lot. It's 9 terms. And it's 1 over n factorial. So 1 over 0 factorial is 1. 1 over 1 factorial is 1. 1 over 2 factorial is 2. 1 over 3 factorial would be 1 times 2 times 3. That'd be a 6. 4 factorial, that's a 6 times 4 is 24. 5 factorial, and feel free to use your calculator. Remember, it's under math, and then go over to probability. 5 factorial is 120. 6 factorial is 720. 7 factorial is 5040. And 8 factorial is 40,320. So you're going to add all this up in your calculator, and you're going to get 2.72. Okay, so 41. You're starting with 1, you're going to 6, and you're doing 2 over I factorial. So I'm going to give you 30-second head start. Dive on into 41. Feel free to use your calculator. Okay. And then type that all into your calculator and get a decimal. And you should get just under 3.5. Okay, 42. So I'm starting with 1. I'm headed to 5, and I'm doing a lot to it. So I'm going to have chicken scratch above here and final answers below here. So if I plug in a 1, that's going to be negative 1 to the 1 minus 1, which is 0, times 1 factorial. Well, negative 1 to the 0 is 1 times 1, so I got a 1. All right, now I'm going to plug in a 2. So negative 1 to the 2 minus 1, which is 1, 2 factorial. So negative 1 to the first is negative 1, 2 factorial is 2, so negative 2. Now I'm going to plug in a 3. So negative 1 to the 3 minus 1 would be 2 times 3 factorial. And again, I encourage you to pause this if it's going too fast. Negative 1 squared is 1, and 3 factorial is 6. Okay, let's see, that was a 1, 2, 3. Now I'm going to plug in a 4. Negative 1 to the 4 minus 1 is 3. 4 factorial. Negative 1 cubed is a negative 1. And 4 factorial is 24. So negative 24. And then I have one more. Negative 1 to the, plugging in a 5. 5 minus 1 is 4. 5 factorial, that would be a positive 1. And 5 factorial is 120. And then you add. 0.101. All right. Okay. So now we're going to talk about an infinite series, and we're going to sum the first n terms of the sequence, and that's called a finite sequence, or the nth partial sum. The whole sum would be the infinite sum. And it's denoted by, so I'm going from 1 to n of all the terms, and the sum is the adding part. So the sum of all the terms in an infinite sequence is called an infinite series, and it's denoted, the only difference is the top. Instead of stopping at a specific value n, I go all the way to infinity. Now, let's wrap your brains around that for just a second. You're going to find the sum, like a number, of a series that never ends. So the only way that can happen, if you have a series that gets bigger and bigger and bigger, and then, I mean, if it just keeps getting bigger and bigger and bigger, this sum is going to diverge. Now let's talk about the difference between diverge and converge. Diverge means it goes on and forever. It's going to get huge and huger and even huger, and it's never going to approach a value. Converge means that it converges to a particular number. It's never going to get there, sort of like an asymptote, but it's headed towards a number. And the only way that's going to happen is if your series is getting smaller. And your job is to find the sum that it will just barely never reach. Okay? So this is the sum of a sequence or a series that never stops. Okay? This is the sum of a finite series. So like if I stopped this right here, I can find the sum of this. I just add them all together. Okay, so let's see what these look like. It says finding the sum of a series. This is for the series from 1 to infinity, 3 over 10 to the I. Find, now there are two parts. Part A, the third partial sum, and B, the sum. Well, for A, I want the third partial sum, so I'm not headed to infinity. I want to go from 1 to 3, as it said the third partial sum. Okay, so I'm going to plug a 1, a 2, and a 3 in. So I have 3 over, if I plug a 1 in, that'd be a 10. If I plug a 2 in, that would be 100. And if I plug a 3 in, 10 to the third would be 1,000. Now, before you just go straight decimal, think about this. Think about what a common denominator would take. Well, my common denominator would be 1,000. So he would need to be multiplied by 10. And he would need to be multiplied by 100. You see how easy that is? Now add the top numbers together. That gives you 333 over 1,000, which is the same thing as 0.333. Now, not repeating. That's a finite sum. It stops right there. It is exactly 333 thousandths. Okay. Now for part B, I want the sum from 1 to infinity. Okay, so literally I want this to go on forever. Now I also want you to notice one thing. This value, total value, as I get bigger, overall the fraction is going to get smaller. Go back and look up at part A. Look at the purple numbers. Ignore the blue zeros. You had 3/10. which is a good solid fraction. Then you had 3 100ths. Okay, well that's smaller. Then you had 3 1000ths. So do you guys see that this is getting smaller and smaller as you go down the line? That's the only way you can find the sum of an infinite series. The series has to be getting smaller. So our job is to find the number that the sum is approaching. Well, if you think about, we found the first 3 terms of this series in part A. So it was 3 tenths, 3 100ths, 3 1000ths. But for this one, I need to keep going forever. So then it's going to be 3 over 10,000 plus 3 over 100,000. So think about what that's going to equal. And I can't write that as a fraction because this is a finite number. But if it's 3 tenths plus 3 hundredths plus 3 thousandths plus 3 10,000ths plus 3 100,000ths, so his sum is 0.3 repeating. Okay, so now we're going to do the exact same thing. We're going to try it again for a different series. And let's see if this can sink in solid. Okay, so here's my rule. It's the series, the sum of the series from 1 to infinity. I want the 4th partial sum, and then the sum, the whole sum all the way to infinity. So I'm going from 1 to 4. Okay, so I'm going to plug in a 1. That's 5 over 10. Plug in a 2. 10 squared, that's 100. 10 cubed is 1,000. Then 10 to the 4th is 10,000. Common denominator is 10,000. Get my common denominators. So that's well, if I did a fraction first, that's 5,555 over 10,000, which as a decimal is that exact decimal, not 0.5 repeating, it stops, it's finite. So for B, the sum from I to infinity is going to be all of this, but it's just going to keep going. So his infinite sum is going to be 0.5 repeating. And again, notice this sequence, the individual terms are getting smaller and smaller and smaller, and that's the only reason I can find an infinite sum. It has to converge on a number. Diverge means it gets bigger and bigger and bigger forever. Okay, here we go. So I want the 3rd partial. So I equals 1 to 3 of 9 over, okay, now this is different. I have 100 down here. So the first term out of the 1, or 100 to the first power would be 9 over 100. And then 9 over, let's see, 100 squared is not 1,000, it's 10,000, because it would be 4 zeros. And then 100 cubed so this guy is not going to be 0.999 or 0.999. It's going to be, that's 0.09, that's 0.0009, and that's 0.000009. So it's going to be 0.090909. So then his infinite sequence is just going to be more and more and more and more of these, which means the pattern is just going to continue forever. So 0.09 repeating. So again, make sure that you're good on everything. Feel free to go back and watch the video if there was a piece that didn't sit well with you. And then you're going to pick up with your homework, let's see, for number 87. And it should go relatively quick.